Hey, welcome to Tammy the Tutor. Today we're in CC2 lesson 1.2.3. Number 80. Tom keeps all of his favorite marbles in a special leather bag. Right now, 5 red marbles, 4 blue marbles, and 3 yellow marbles are in the bag. If he randomly chooses one marble to give to a friend, what's the probability that it is blue? Okay, so we just need to, I'm going to get organized over here. I'm going to write there are 4 blue, 3 yellow, and 5 red. So when you're doing a probability, you need to create a fraction, and the denominator, or the number on the bottom, is always the total number possible. So we just need to add up all the marbles that are in there. 4 and 3 is 7, plus 5 is 12. So out of 12 total marbles, how many of them are blue? And you can see right here that 4 of them are blue. And then you should reduce. So to reduce 4 12ths, divide the top and the bottom by 4, and that's 1/3. So that's the probability that he will pick a blue one. B, Tom does not really want to give away blue marbles and would like to change the probability that he chooses a blue marble to 1/10. How many marbles that are not blue could he add to the bag so that the probability of choosing a blue marble becomes 1/10? Okay, that sounds like a really confusing question. So they're saying right now the probability of him getting a blue marble is 4 out of 12, right? And I know we reduced it to 1/3, but technically, yes, it's still 4 12ths. He doesn't want to give away a blue marble, so he wants that probability to get smaller. So he's thinking, what could he add to the bag so that the probability of getting a blue is smaller? He's going to add other colors. And that's not the point right now of which colors. We just need to figure out how many marbles that we do need to add to the bag. So really the easiest way to think about this, he wants to change the probability from 4 12ths to 1/10. So let's think to ourselves. The 4 is not going to change. He has 4 marbles in there, period. He's not taking away or adding to the blue ones. So if that's not going to change, let's come up here and get rid of that. What would the denominator need to be in order for that fraction to reduce to 1/10? So think about that for just a minute. Think about your giant 1. Okay. Let's go from this side to this side. How did I get from 1 to 4? I multiplied 1 times 4 to get 4. And this is a giant 1, so if 4 is in the numerator spot, a 4 must be in the denominator spot. So do the same thing to the bottom. 10 times 4 is 40. Okay. So if he has 4 blue marbles out of 40 total marbles, then the probability of picking a blue one goes to 1/10, and that's what he wanted. So, but the question is how many marbles do we need to add to the bag for this to happen? Well, if there used to be 12 marbles, but now we want there to be 40 total, how many did we add? And that would be 28. He added 28 marbles that were not blue to change the probability to 1/10. Number 81. Your team is in charge of games at the CPM amusement park. One of the games involves a robotic arm that randomly grabs a stuffed animal out of a large bin. You need to set up the game so that the probability of a customer's grabbing a teddy bear is exactly 1/2. How would you set up the bin? Okay, this is just one of those bins that you will see. Like if you go to Wahoo's, there's actually even one, like when you're leaving Winco, they have those big containers and they've got filled with toys and stuffed animals, and the big claw comes down and randomly grabs one. So they're just saying, if you were in charge of setting this up and you know you have teddy bears and other things in there, how could you make sure the chances of grabbing a teddy bear is exactly 1/2? Well, the answer is there has to be the exact number of teddy bears, as there are the other animal. Let's just pretend the other one's a stuffed frog. So there has to be the same amount of teddy bears and frogs. That's how you would set it up. B, what if you returned to check on the bin and found that there were 4 teddy bears left and 12 other animals? What could you add to or remove from the bin to return the probability of selecting the teddy bear back to 1/2? So if the whole goal is to make sure there's the same amount of teddy bears and frogs, let's look at this. There's 12 frogs and 4 teddy bears left. Well, you can either add 8 teddy bears. So you can add 8 teddy bears so that there's now 12 teddy bears and 12 frogs. Or you could take away 8 frogs, which would leave you 4 frogs and 4 teddy bears. The whole point, remember, is you have to have the same amount of teddy bears and frogs. Write 4 different fractions that are equal to 1. Use your calculator to check. Oh, you don't need to use your calculator on this. That's kind of silly. Fractions that are equal to 1. Okay. You get the point? Are all of these fractions equal to 1? Yes. Okay. 83. A rectangular park is 150 yards on one side and 125 yards on the other. If Debbie walks around the park 2 times, how far does she walk? Sketch a figure and show your work. Okay. They said a rectangular park. They said one side's 150 yards. The other side is 125 yards. Okay, if she walks around the whole thing twice, how far has she gone? So, if this side's 150, this side's 150. If that's 125, this is 125. So let's just figure out how much it would be if she walked around the whole park one time. And around the whole park means wherever she starts, she goes this way, this way, this way, and then back to her starting point. So really, we're just looking for the perimeter of this park. So 150 and 150 is 300. 125 and 125 is 250. So add them together. So that's 550 yards to get around the park one time. So to get around it twice, we just need to double 550. And so that would be 1,100. Okay, so there's the answer for A. So B, if Debbie wanted to walk 1 million yards, how many times would she have to walk around the park? Okay. So we know it took 550 yards to go around one time. How many of those 550 does she have to walk before she reaches 1 million? So you have 2 choices. Well, you're going to divide, obviously, right? So you could either do some long division, or you can use your calculator. As a math teacher, I, at this point, would say just go ahead and use your calculator for this one. Sometimes the most important thing they're looking for is that you would know to use the operation of division, okay? By now, you should know how to do long division, and that's probably not what your teacher's biggest worry is. Although, if you're not super strong in it, then you should practice. So, here's the answer. I choose my calculator just to get there quickly for you. You would have to walk around 1,818 times. 84. Find the perimeter and area of each figure below. So A is just a trapezoid, or a trapezium to be more exact. I think it might be easier if you picture this one on its side. I'm going to draw it. And the reason why I call this a trapezium instead of a trapezoid is they're still in the same family and they still work the same way. But a trapezoid has both of these sides slanted in an equal way, usually. But sometimes this side can be straight up and down. Okay, still in the trapezoid family, because the definition of a trapezoid is that, well, number one, it's a quadrilateral, which means they have 4 sides, but they only have one pair of parallel sides. And here are the parallel sides right here. These two are not parallel, but also they're not parallel over here either, okay? So let me label this. This side is now here. This is now the top. This is this side. And then 15 goes here. So let's just take care of perimeter first, because that tends to be the easier one to do. And perimeter is just adding up all of the outsides. So we have 11 and 9 is 20, 20 and 15 is 35, and then let's do 35 plus the 9.85. Okay, so here's perimeter right here. Oh, we cannot forget to label meters. Let's jump over here and do perimeter really quickly too. Perimeter, let's add up all the sides. So we've got 14 and 9 and 7. I know they show this dotted line, but that's just for the sake of helping you find area, because for the height of area you need a straight up and down line, and this one didn't have one, so they just kind of showed you from the highest point to the lowest point to make a straight up and down. That measurement is 4 meters. However, the perimeter, you really need the actual 3 sides to add up. So 9 and 7 is 16, and then 16 and 14 is 30. That's 30 meters. Okay, now let's come back over here for the area. Let's do area of the triangle first. It's base times height and divide it by 2. So the base is 9. The height is not the 7, not the slant. It's the straight up and down, and that's why they gave this to you. And that's 4, and then you divide it by 2. You can do 9 times 4 is 36, divided by 2, and then you have to divide that in the end. Or you can go ahead and divide one of these numbers by 2 right now, and I always do if one of them is even. So 4 divided by 2 is 2, and the 2's gone now. You've used it, so that's why I crossed it out. So now all I have left is 9 times 2 equals 18, and 36 divided by 2 is 18, and the label is millimeters squared. Okay, so area of the trapezoid is the same as the formula for the area of a triangle, except it has 2 bases, and so you have to add your bases together. So let me say it's base 1 plus base 2, and then you still divide it by the times the height and divide it by 2. I'm sorry, I think I said divide up here, but it's multiply times the height. Okay, our bases are 15 and 11. So 15 and 11 is 26. Our height is the straight up and down, never the slant. And then divide it by 2. And yay, one of our numbers is still even. So I'm going to say 26 divided by 2 is 13. And then now I just have to do 9 times 13 is 9 times 3 is 27. 9 times 1 is 9, 11. Okay, so 117 meters square. Sorry, this one over here was also just meters, not millimeters. Okay, that's it, you guys. Good job. I know that probability might be feeling a little scary for you, but you've just gotten started. You're going to do it a lot more during this school year, and believe me, it gets a lot easier, so just hang in there.